Hello everyone, I would like to comment on this team's Lab 3 assignment 1. So let's check the requirement first. The first assignment is visualization of mosquitoes population. We have a file, and this one is the CSV file here. And then they have two kind of mosquitoes, one is this and one is this. And then it have features like vector, location, polygon, admin, type, X and Y, and year, country, country ID, blah 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 things here. Okay, then we are asked to using the map box interface in Lab3 to create two dot maps. Okay, then show the distribution of two types of mosquito in the world, and using colors to distinguish them. Then analyze the two plots, okay, just like here, and then find some perception problems in those plots. So let's check the code. So here, first of all, he read the data into memory, into R session, which is like here, no problem. But here's the one thing we should mention, because let's check the CSV file. They have a header here. Yes, we know that this read.csv file may have a default value, which may be the header equal true or something like that. But it's better to set the header equals true here, to let the user know or reader know that this file has a header. And then he extracts the mosquito data from each year. So he using the which, and we set a filter, and this one will get an index, and then we get the mosquito of 2004 and the mosquito data of 2013 separately, and then call the plot map box function provided by Lab3, and then set this and set a map box token here, and then plot the data. Okay, there's no big issue here, and I have one concern is the color is set by the here by Lab3 automatically, but it chooses two very close color, which is not easier to distinguish them. So it's better to manually specify the color of two kind of mosquitoes. So, and then the key things is here, we need to set the scatter plot box so we can see this. And another one is we should zoom the map. So this one is the default zoom of this team. Yes, their code did not set any zoom info here. So it's better to zoom to 0, which means we can see the whole map at the initial state. And this one is also, we should do the same, just like this. Okay, but how to do this? Okay, I will show you how to do this here. So here 101, 1.1, we should set the zoom just like this, layout, map box, this, blah blah blah, and the zoom equals 0, which will set the zoom like this. So the user will know which country have the most interesting things, and then zoom, and drag and zoom like this. So this is my comment, and also we should add a title here. You missed that because he using the variable name like a figure 04, but we need to check all the code to understand what this one really means. So it's better to write some title here to let the user understand it quickly. Okay, then let's check the analyze which country and which region in this country have the high density of each mosquitoes. Okay, from here we know that now the blue one here in American and the you know the yellow the green one are here in the South American, maybe here between them, and we also find the blue mosquitoes in Asia, maybe somewhere in the Europe and here. So and some green mosquito here. And also, we found that in this 2013 map, we found that the mosquito here almost disappeared. But we found something here, which is a lot of cases in Brazil. Okay, and that's it. That's the things we can talk about. So let's check the answers of this. The plot is rather zoomed out, no problem, and and as a fixed dot size is used, you get impression that the covered area of one observation is in fact larger than it actually is. No problem. There's also lead to impression that almost entire surface area of Brazil seems to be covered. Yes, we can saw that because it seems that Brazil is covered by the green dots. Apparently from the plot from different year is that this kind of mosquito was more frequently than, so let's check AEDE, so that means the green one. No. Yeah, the green one. No, the green one is more than here. Yeah, it's very clear. That means this one only limits things in South Asia, and some of them in Africa, and some of them in South American. But here in Brazil, we found a lot of them. So this is a thing we discovered. Okay, and he also mentioned here, this is great. And at the same time, one can observe areas such as USA here. Laos, Thailand, decline in observation is made. Yes, we can see that because there's a lot of cases here, but here is almost empty. So this is true, and this kind of mosquito is observed numerous times in the USA 2004, but only once on the west coast in 20. So we can find that there's a lot of blue dot here, but here it's almost disappeared, and only something in the west coast. Okay, yeah, I totally agree with this. But yes, apart from the issue I mentioned, I think. Oh yeah, but this team forgot to mention that the perception problem can be found in this plot. The things I would like to mention is, yes, here it have a lot of it's very clear things is we can find a lot of cases in Brazil, and some points here, maybe in Europe. Okay, it's in Italy. Okay, and we also found a point here, an area here, it's Taiwan, and maybe at the very beginning we may think they have the same amount of detection cases, but if we zoom it, we will find in Taiwan, okay, there's a lot of them, okay, detection cases, and maybe in 100 or 1,000, but in here, in Italy, at first we may think they're the same, but if we zoom it, we found that only maybe 10 or 8 detection cases here. So this is a problem, which means they look like the same thing, but a lot of them compared to maybe only 10. This is a big issue because we may ignore this and only focus on the Brazil area. So that's a case we should comment, but this team forgot to mention this. Okay, so for the question 2, let's check the requirement that we need to compute Z as the number of mosquitoes per country detected during all the study period. Then using plot GIL function to create a map, show Z value. Okay, and then answer the question about why do you think there's so little information in this map. So let's check this one. So let's check the code. First of all, he set a projection type. Then using df mosquito, and then set by country, count by country ID, and then plot GIL and add a trace, and think there's no big issues. But what I would like to comment is it's better to using the same color instead of default color from yellow to dark, maybe blue. Okay, and we may see that from here, one is Canada and one is USA and one is Mexico, and we cannot find the difference between them, because if we only check it here, it's hard to remember which one is much more than another one if they share the same colors. But we only know that the yellow one is greater than the blue one. So I think it's better to change the color from the dark blue to the light blue or some other same colors, not using this kind of color. So then okay, the map have been okay. Then why do you think there's so little information on the map? In the map, my understanding is yes, that's because we're only using the color to show the how many detection cases in each country. And another thing is, in this map is he only if we move the mouse on top of each country, it will only show a total number of detection cases, which is a tiny bit of information can provide it. So that's because it's using aggregation, and it's only show one information and the colors. So I think that's the reason why it's only show so less information. And let's check this. I believe the main reason is there's so little information is rather aggregate when we count them by country. I agree. One could argue using nation border isn't optimal, but rather we should aggregate over latitude and longitude. And also the scaling level applied to attitude issue. And we are, for instance, grade Canada with one observation the same as Mexico for 165 observations. So I think for the last one, this one is not a big issue because it's scale. Let's see, from 0 to 20k, maybe 25k, maybe here. So I think 400 is not a big one in here. Maybe 0 to 400, maybe almost same. Even if we using the same color from the dark to the light. So even we use that, we cannot find the difference between them. I mean, just by color. So I think this one is not an issue here. Okay, so if we using the different color, if we use the same color, I will show you my implementation. Okay, here the number of occurrences. Yes, we also should add, change this one to a meaningful things. Okay, and for example here, 465 and this one is still almost same. But even with USA have 2044, they still have a big difference between them if we just check them by color. So yes, I think this one is should not mention here. Okay, then Then third one. Third one, we need to create the same kind of map as step 2, but using log. Okay, then analyze 3A and make conclusions, compare 3A and 3B and comment the pros and cons of those two different kind of maps. So let's check the code. But first of all, we set equal rectangular projection, and we also set another projection type. Then we're using this one to get the DF mosquito and count them by the country, and using plot GIL and then add a trace. This is no big issues, and then we assign the projection type and plot them. The thing is here, as I already mentioned, we should using the different colors. No, he using different colors, but I highly recommend that we using a same color. I will show you why. Because if we using the same color like this, I will show you here. If we use the same color, yes, we can know that this one is definitely smaller than this one, and because American is much more darker than the Mexico, then definitely it's much more higher than higher detection cases than Mexico. And if we check out the Brazil, it's much darker than American. So I think yes, using the same color, it's much easier to identify the cases. But here, if using the different colors, and for this and this, we can maybe something like this. It's hard to identify which the higher if we compare two different countries, or maybe even here. Maybe you think this one is have greater cases, more cases, and this one has less cases. We have to check this scale to identify which is higher. So I think it's better to change the colors using one color. Okay, then this one is the conic equal area projection, which is good. Okay, no big issues, I think. But yes, we should also change the colors to the one unique color, not using the from the yellow one to the dark blue one, but with the little green ones in the middle. So it's better to using one color. And yeah, so this one we can know, and we don't need to check this scale. And we know which country has more detection cases easily, directly. So let's check analyze the map from 3A and make conclusions. Here. So from here, theoretically, it's hard to identify, but but from my map, I think yes, here. We can see the Brazil has more cases than the USA. Then maybe but I think, and maybe here, but still USA. But here, this one is almost same with the countries in Asia. But these and maybe some countries almost share the same level scale. Okay. So let's check the answer of, let's check this team's answer. So in the plot with the rectangle, the main advantage of that, he would like to say the advantage and disadvantage of this one is the observer get overview of the world and can see roughly which area has more affected. Disadvantage with an overview, you tend to miss details. The scroll function can help, But instance like Taiwan, the country with most observation, is rather hard to spot given its relative size in the graph. The color grading, the yellow, okay. He also mentioned the color, which can be solved by setting using one color from the light to the dark, which can be solved. So this one is not an issue. And the scroll function, okay, works like this, and we drag it, and we can see it, okay. But yeah, from definition of the rectangle plot, I think it's you know, the distortion of this projection will most affect the polar area from here and here. But most of the country, I think there are no big issues, but the country near the polar area will have a great influence. Will have a great infections. So, and for this one, I think you know, the shape or the size were not affected by the projection. But things is, we only can see a part of the map, so we have to, you know, drag it to see all the details we want to see. Okay, and so my understanding of this, okay, is pro and cons, and one is projection is a cylindrical, and the conic is a projection type, the conic. Okay, is this no? And area preservation is, this one is no. We don't keep the area because especially the polar area. And also the shape preservation, this one at the pool especially, as I mentioned before, is the polar area, because you know, actually this one is not too as large as this one, but actually is smaller than this one. Okay, and the distortion is high, especially still near the polar area, but this one, because it's using the conic projection, so the distortion may be better, much more better than the equal rectangular projection, and its shape is keep the original shape, and area preservation good. But the disadvantage is we have to, you know, drag it because we cannot see all the things in one go. That means we need to try to do this continuously. So let's check the answer of this. Let's check the answer here. In the plot with rectangular projection, the main advantage, yes, he already mentioned that. Yes, sorry. And then in the plot with conic projection, the issue faced previously is overview showing and time world is reduced. Yes, as I mentioned that we have to, you know, drag it, and it's more focused on less surface area. I agree. Zoom twice yield a good visualization on the instance of Europe and Central Asia. And of course, the very south tip of South American and Australian gets a bit deformed. And let's see, you know, here. It looks like weird, but because most of the country is still the same as expected, so it's not a big issue. And the country near this line, they don't have a lot of countries, so only maybe Argentina and Australia, so it's not a big issue to in our case. Then, so in Lab 4, in question 4, in order to solve the issues, we need to create a grid, which means split X to 100 pieces, split Y to 100 pieces, then make 100 times 100 grid. and then you calculate the mean value, and then plot again. Then also, he also asked, did such this creation help you analyze the distribution of mosquitoes? So let's check the code. Okay, so this one is still have issue. Okay, it shows the Brazil, but since we are only focused on the Brazil, it's better to move this one in the middle and zoom a little bit like this, so the user can know, can see very clearly at the very beginning. Okay, then we check the code, df mosquito, then use a filter, we filter the data of Brazil and the date year 2013. Then create two values, x1 and y1, and then group by x1 and y1, which means we group by their grid, make 100 times 100 grid, and then we get the x mean and the y mean, and also get the number of the observations in this grid. Then we're using the plot map box, just like this. So this one is have no big issues, just the things I mentioned before is we should move this one in the middle, and I will show you what I did. And okay, then here the code 1.4. Yeah. So first of all, I get the data of Brazil in 2013, and create a variable to cut to 100 pieces, and then y for 100 pieces, and then group it just like what he did here. Okay, here group by, I will say. Then I also set the Brazil center latitude and longitude, so we can see this one in the middle. And also then we using plot array, set the type as a scatter map box, set the longitude and latitude, and set the color, and set the marker size, but it's optional. Then set the zoom so we can see like this, and also set the center. So yes, we will set the Brazil in the middle, so the user can see all the data in one go, and don't need to try to move left and right or zoom. Then set a map box token. So yeah, and let's check identify regions in Brazil. Okay, the regions that are most infected by mosquito, I think from this plot, I think it should be here, the yellow one. Okay, maybe something here, but not a lot of things. So I think it's in the east part of the Brazil had the most detection cases. So the region I'm most affected by mosquito is the eastern part of this one, as well as around São Paulo and blah 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 area. The distribution helps, I agree. And for this sentence, yes, I agree. Yes, and especially this part. I also know that the color grading is much better suited for this level of plotting, as the contrast shape in the relatively dense area where the observations are made, in contrast with the background in question 1. Okay, for the default color, I think, yeah, it's good, because it's using the dark blue and yellow as a default color. So, because he did not specify any kind of colors here, so if he really want, if for example the background, if the background become the dark colors or things like that, or in some special cases, it's better to set the colors manually. So yeah. to make sure in every case it will fits the data well, or fits the data and plots this kind of map well. Yes. So that's the end of the assignment 1. Thank you.